In this video, I am going to explain the concept of enantiomers, diastereomers and Meso compounds. Compound A contains the chiral carbon. It's a chiral molecule because this carbon contains 4 different groups. But compound C, this carbon is not chiral because it contains same groups. Now compound A and compound B, they are mirror image of each other and they are non-superimposable mirror image. So A and B are called enantiomers. C has a mirror image D, but C and D we can't say enantiomers because the carbon is not a chiral carbon. So since it's not a chiral carbon, it cannot generate any stereoisomers. Enantiomers are type of a stereoisomers. They are non-superimposable mirror image of each other. Since enantiomers are identical type of molecules, so they have identical physical properties like solubility, melting point and boiling point. It is difficult to separate enantiomers. Diastereomers are a type of stereoisomers. This type of isomerism is possible when a molecule contains more than one stereogenic center. Now we'll explain the diastereomers using an example 2,3-dichloropentane. We can draw the 2,3-dichloropentane as a Fischer projection. So we have drawn two structures A and C. Now B is the mirror image of A. So these are non-superimposable mirror image. Similarly, D is the mirror image of C. These are the non-superimposable mirror image. So that means A and B are enantiomers, C and D are enantiomers. So we can say that A and C and A and D, they are diastereomers. Similarly, B and C and B and D, they are diastereomers. Diastereomers are different compounds. So they have different physical properties like solubility, melting point and boiling point. And that is the reason the diastereomers can be separated by fractional distillation. Let's understand the concept of Meso compound. Meso compounds contain stereogenic centers, but it has plane of symmetry. That's why the molecules is not chiral. Here I have taken one example 2,3-dichlorobutane and have drawn the structure as Fischer projection. So there are two types of Fischer projection has been drawn, compound A, compound C. A and B, they are non-superimposable mirror image of each other. It contains two chiral centers. So they are enantiomers, chiral molecule, that means optically active. Now if we look into the structure of C and D, they contain two chiral centers. But here we can draw a plane of symmetry and then they will be mirror image of each other. Though two stereogenic centers are there, but since they contain plane of symmetry, so as a whole molecule is optically inactive. These type of compounds are called Meso compound. So compound C and compound D are Meso compound.